Inverse Laplace transform. See, inverse transforms are used to convert frequency domain to time domain. See, up to now we have discussed how to convert time domain functions into frequency domain, and sometimes we have to convert frequency domain to time domain functions. So to convert frequency domain to time domain, inverse transforms are used, right? So now the topic name is inverse Laplace transform. Inverse Laplace transform. So inverse Laplace transform is used to convert frequency domain to time domain. So the basic equation equates like this. Laplace transform of f of t is f of s. So time domain is converted into frequency domain. Then inverse Laplace transform. So inverse Laplace transform purpose we have to use this symbol L inverse, right? So inverse Laplace transform of f of s. Inverse Laplace transform of f of s is f of t, right? So inverse Laplace transform is used to convert frequency domain to time domain. So s domain function converted into time domain function. So to find the inverse Laplace transform, two techniques are used. One technique is long division method and another is partial fraction method. Partial fraction method. If the power of the numerator is less than the power of the denominator, then the functions are called proper functions. For those type of functions, partial fraction method is used. If the power of the numerator is greater than or equal to power of the denominator, then long division method is used. So first of all, we'll go through the partial fraction method, right? So partial fraction method. Partial fraction method. So for that purpose, we have to take always proper functions. So now I'm assuming one equation here, f of s is s plus 2 by s plus 1 into s plus 3. One s domain equation is given now. One s domain equation. Now we have to find time domain function. So apply inverse Laplace transform. So find f of t. The question is here f of t. Find f of t. So for that purpose, first of all, we have to apply here partial fraction method. Partial fraction method means the complete function is divided into sub functions. So for that purpose, here I am taking like this. Denominator consists simple roots here. S plus 1 and s plus 3 is there. Write like this: a by s plus 1 plus b by s plus 3. So a is some constant and b is constant. A by s plus 1 plus b by s plus 3. First of all, we have to check power of the numerator should be less than the power of the denominator. See, power of the numerator is how much here? 1. And denominator power is here 2. Because if you multiply this, which gives the maximum power is s square. So denominator power is 2. Power of the numerator is less compared to the power of the denominator. Then partial fraction directly apply here. So a by s plus 1 plus b by s plus 3. Now we have to find out a value and b value. See, to find a and b values purpose, here I will explain one simple technique. The technique is like this: a value. To find the a value, the complete function, take complete function f of s as it is. F of s multiplies with the denominator of a. The a denominator is here s plus 1. Write like this. And substitute s is equal to minus 1. Because here we have to take s plus 1 is equal to 0. Then s is equal to minus 1. So then it gives it directly a value. See, what is f of s here? This complete function. S plus 2 by s plus 1 into s plus 3 into s plus 1. Then s plus 1 cancels. S plus 1 cancels. And the remaining function consists here s plus 2 by s plus 3. Then substitute s is equal to minus 1. Substitute here minus 1 plus 2, minus 1 plus 3. Then which becomes here 1 by 2. 1 by 2. Similarly, now I want to find b value here. So b denominator is s plus 3. So this complete function multiplies with s plus 3, right, like this. F of s multiplies with s plus 3. And we have to substitute s is equal to minus 3. S is equal to minus 3. Write f of s here, this complete function. If it is multiplies with s plus 3, s plus 3, s plus 3 cancels, then the remaining function becomes here s plus 2 by s plus 1. Then substitute in this, s is equal to minus 3. Here minus 3 plus 1, minus 1 by minus 3 plus 1, minus 2. So minus minus get cancels. Now finally which gives the 1 by 2. Right? So from this s plus 3 is cancelled, s plus 2 by s plus 1, and in this substitute s equal to minus 3. Minus 3 plus 2 minus 1 and minus 3 plus 1 minus 2. So minus minus get cancels. Now which becomes here 1 by 2. A value is 1 by 2 and b value is 1 by 2. Substitute these two values in this equation. Right? So now finally which becomes here f of s is a by s plus 1 plus b by s plus 2. A value is here 1 by 2 into 1 by s plus 1 plus b value is also 1 by 2 into 1 by s plus 3. Here we have to apply inverse Laplace transform. So to apply the inverse Laplace transform, first of all we should know the inverse Laplace transform basic equations, right? So from the Laplace transform functions, Laplace transform of e to the power of at into u of t becomes 1 by s plus a, right? So inverse Laplace transform of 1 by s plus a, right? Inverse Laplace transform of this becomes this time domain right this side, e to the power of plus at into u of t. If it is a signal, write with u of t, otherwise directly we can write e to the power of plus at, right? So s plus a means here minus symbol, right? So opposite sign is required. E to the power of minus at it becomes 1 by s plus a. Now here inverse Laplace transform of 1 by s plus a is e to the power of at into u of t. So apply this one now. 1 by s plus 1 is there. Inverse Laplace transform of 1 by s plus 1. What is the value? E to the power of minus t into u of t, or we can write e to the power of minus t. Similarly, one more function is there. Inverse Laplace transform of 1 by s plus 3. Inverse Laplace transform of 1 by s plus 3. Then this becomes e to the power of minus 3t into u of t, or this becomes e to the power of minus 3t. So then substitute these values in this here. That means apply inverse Laplace transform on both sides. Apply inverse Laplace transform on both sides. Then inverse Laplace transform of f of s becomes f of t. Inverse Laplace transform of f of s is f of t. F of t is equal to 1 by 2 constant I am writing as this. Inverse Laplace transform of 1 by s plus 1 is e to the power of minus t plus again constant 1 by 2 is there. Inverse Laplace transform of 1 by s plus 3 is e to the power of minus 3t. So write like this, right? Otherwise if you want to write in terms of signal representation, we have to write like this: 1 by 2 into e to the power of minus t plus e to the power of minus 3t into u of t, right? So signal representation purpose into u of t right there, because u of t explains the time limits. For mathematical expression purpose, u of t is not required, because mathematical equations always explains the unilateral Laplace transform. The given signal is defined from 0 to infinity, only pass to time axis side, right? So write either this answer or this answer, both are correct. Now please take this now.